exercise 1. Tangent vector points in the direction or in direction of increasing t, or the parameter t. So we're asked here, show that the tangent vector to a curve defined by a vector function r of t points in the direction of increasing t. All right, so and here's a hint. Refer to the earlier figure also shown below and consider the cases h is greater than 0 and h is less than 0 separately. So consider this cases and basically look at this right here, either less than or greater than 0, and then see what happens to this direction. So this is the this is the derivative right here, and this is the secant. Secant vector as a tangent vector, and as this approaches 0, this becomes the same, and basically saying is t if t is increasing here, this would be in the direction of it. If t is increasing on the other side, it would be this would actually be the vector function. I mean the derivative of the vector function, and that's what it's saying. So we have to prove that, and let's see what happens. So solution. So the tangent vector r prime of t is defined as, so basically this, but the limit as h approaches as 0 there. So we get let's recall the definition. So this is what it's defined as. Again, just for recap, this is equal to limit as h approaches 0 of, now we go r of t plus h minus r of t. So the difference, so the rise, think of it as rise of a run, but this is like 3D with parameters. Now this is going to be h like that. All right, and now here we assume that this limit, this limit exists, and that the derivative r prime of t is not equal to 0. So let's say it exists and it's not equal to 0, and then we know that this vector lies on the tangent line to the curve. So basically, this is the tangent line straight across there. So we know it's going to be somewhere like this, up or down. And so on. So it's going to be in one of those directions. Yeah, so as in the above figure, let points P and Q have position vectors r of t and r of t plus h, and the vector r of t plus h minus r of t points from P to Q. So then the difference right here, r of t plus h minus r of t, is equal to just a PQ vector, or the secant vector. And now I'll draw this all out. So if h is greater than 0, then t plus h is greater than t. So q lies ahead of p. So ahead of p in there. All right, so let's draw this out. So I'm going to draw it like this. This is the I'll draw it like this. This is the y. This is the z. Okay, that's the z, and now this is the x component. Like that, and now this is, we're going to take the case, look at the case for h is greater than 0, like that. So h is greater than 0. So let's say we have a curve like this. Again, I'm just going to draw this one out again, but just draw down. We're going to draw over it. So let's say it's like this. Okay, it's something like that. So this is the point P. So this is point P is going to go at r of t. All right, here I just quickly fix that up, just make it like that. And this is a point P. And let's say we have a point Q right here, and I'm going to just extend this out. Here I just quickly extend it out, and then say this is our point Q like this. Yeah, so now this one right here, this is r of t plus h. So if this is greater than, if this is greater than t, that is, in other words, h is greater than 0. Yeah, so it's greater than 0, so then this has to be bigger than it. So if it's on this side, this would be ahead of it. So basically t is increasing along this side, so t is increasing, increasing, like that. All right, here I just quickly fix that up. So increasing t is on this side where q is quote ahead of p on the curve. Yeah, and this one's ahead, and then basically this difference right here, this r of t plus h minus r of t, that's just going to be this vector. Whoops, this is just going to be this is just going to be PQ. Yeah, so this is PQ. Like that vector. And this is ahead of it. And again, this is just R of t plus h like that. So that's just that one. And again, yeah, you could recall that how you can add vectors. So R of t plus PQ equals to this one. So then to get this one, you just move this over to the other side. And then you subtract them. And right here, if h is sufficiently small, we can take h to be as small as we like, since h approaches 0 in the limit. Then this pq vector or secant vector approximates the curve from p to q. So as you shrink h right here, so this t plus h, it basically gets smaller and smaller until it pretty much coincides with this p and q. They both basically coincide together, and hence points approximately in the direction of the curve as t increases. Basically what it means is, as you shrink this q right here, as you basically make the h approach 0, it gets closer and closer to this, and then basically the p and q pretty much coincide, and what we get is, well, we get the limit right here, r prime of t, and it's going in the direction of increasing t, and going further. So since h is positive, 1 divided by h times pq, the secant vector, is just going to equal to, well, just a positive number or scalar multiplied by this right here, r of t plus h minus r of t, r of t divided by h. So it doesn't change the direction. It's the same direction. You're just going to multiply by that, and points in the same direction. So in other words, this pointing in this direction there, and this right here is going to be pointing across. It's going to be parallel to the PQ. So it doesn't change anything. So this is going to be 1/2. I'll put it fully like this. This is just going to be r of t plus h minus r of t divided by h. So again, this is in the direction of the increasing t. And then as you shrink it, as you get q closer to p, in other words, h approach 0, this becomes in line with this. That's the tangent line. This is a secant line, which is the same direction as this, like that, because you're just multiplying by 1 over h, just a scalar, not changing anything. We're only changing the length, and not changing the actual, direction, like that. All right. And going further, so if h is less than 0, then what we're going to have is t is greater than t plus h, so q lies behind p on the curve. So here's, I just took the exact same one, I just copied it and pasted it here. So now let's take a look at the case where h is less than 0. So if we have h less than 0, so again, what this means now is, instead of having a scenario like this, we actually need to go backwards. So let's pick our point P right here. So that's our point P. This from here to here is going to be our R of t. And now this is going to be our new Q, just to illustrate it, instead of dealing with the exact same points. So now this from here to here, this is going to be R of t plus h, like that. And now this part right here, again, this right here is less than, because h is negative, it's less than 0. So this is going to be less than t. So this is going to be, I'll just put a less than t. So t is greater than this one. So in other words, this is going to be, this is basically behind p. But in this case, if this is t there, if this is less than this one, so we still have an increasing t here. So we still have increasing t like this. And here I quickly just pause video and just copy and paste this increasing t. So we're still graphing it such that we're increasing the curve, the t from this side over there. But now this q is on this side, so then this pq is going to be coming across this side like that. So that's our pq. And now we'll just read out what I wrote here. Again, it's from the solutions manual. So for h sufficiently small, pq approximates the curve but points in the direction of decreasing t. So this is pointing now decreasing t. So if increasing is on this side, so now this is going towards decreasing. However, h is negative. It's because h is negative. So 1 divided by h times it by pq is going to be, well, this is a negative number. I mean, this is pointing. If this is pointing in the direction going negative, but now you're multiplying by a negative, so it's going to be this this vector r of t plus h minus r of t divided by h points in the opposite direction because of the negative sign. That is in the direction of increasing t. So in both cases, the difference quotient r of t plus h minus r of t points in the direction of increasing t. So in other words, this right here, and I will draw this right here. It's not going to be pointing this way. So now notice this one is pointing this way, but then now we're going to have a pointing this way, like that. This is going to be over here, This will be our, I'll draw this, where could we write it here? Yeah, I'm just going to say that's going to be opposite of that. That's going to be, I'm just going to write this as 1 over h pq, like that. And which is the same thing as the, again, it's the same thing as this one, but now the h is negative. So it's going to be pointing opposite of this. And I will draw, again, this is parallel to it, parallel to this one. But it's in the opposite direction. And going further, right here, in both cases, difference quotient points in direction of increasing t. So it's, again, it's pointing in this direction of increasing t. And then the tangent vector r prime of t is the limit of this difference quotient, so it must also be point in the direction of increasing t. So then this is going to be basically once you get it exactly. Yeah, well, I mean, since this is q, this is approaching here. So once as h approaches 0, this q is going to be moving to the right. So we're actually going to have a tangent. It's actually going to be like this. I'll erase this thing here. Let's say the curve is like this. So then the tangent's going to be actually like this. So it's in the direction. So this is going to be our r prime of t. And this is in the direction of increasing t. So there it is. So regardless, it's always going to be increasing t, regardless if h is negative or positive. Hence, we proved this setup here. So show that the tangent vector to a curve defined by a vector function r of t points in the direction of increasing t. So the direction vector, the tangent vector is always pointing in the direction of increasing t. So if you want to know which way a function or which way is the t increasing, you could either graph it yourself or just take the derivative at any point, and you'll know where it's going there.